So what is EMS? Electrical muscle stimulation. Whether you're looking for a tool to boost your fitness and strength or recover from an injury quickly, electrical muscle stimulation can help achieve that goal and many more. But with that comes a lot of questions like what exactly is EMS, EMA, NMES, TENS? So these are common questions I get at events, where we're demonstrating BB Tech uses and benefits. To avoid, some confusion, let me clarify. EMS is electrical muscle stimulation, EMA, electromuscle activation, NMES, neuromuscular electrical stimulation, and TENS, transcutaneous electrical nerves. EMS, electrical muscle stimulation, EMA, electrical muscle activation are two terms that are often used interchangeably, but they actually have some subtle differences. Right? EMS is a broader term that refers to any technique that uses electrical currents to stimulate muscle contractions. EMA is a specific type of EMS that targets and activates the specific muscle fibers or groups. EMS can, be used in various different ways for a few different purposes, such as physical therapy, fitness, rehabilitation, and even cosmetic enhancement. EMA can be used for specific goals, such as increasing muscle mass, strength, endurance, or power. EMA can also be used to prevent muscle atrophy and improve muscle recovery. So most human movement is stimulated by electrical impulses generated naturally by the body. The same stimulation can be safely artificially generated through modern technologies, such as electrical muscle stimulation and electrical muscle activation. Now, many people have been in physical therapy and may have no experience TENS, TENS, or NMES devices, but we're not actually educated on the differences between the two types of stimulus. TENS and NMES target different nerve groups of the body. So TENS is specifically targeting the sensory nerves, which are responsible for sending pain signals to the brain. NMES targets the muscle itself, specifically through motor nerves. Right? So this allows the NMES machine to create a muscle contraction to recruit more muscle fibers when training, warming up, and recovering. Sensory and motor nerves fire at different frequencies, which is why NMES and TENS devices affect the body differently. So the TENS is the use of an electrical current to stimulate nerves for therapeutic purposes. So the TENS stimulates the sensory nerves, surpassing the pain signals that are being sent to the brain to give the user relief. In other words, TENS kind of tricks the brain to ignore the pain for a short duration of time by applying a non-painful stimulus to the same area. So NMES uses electrical muscle stimulation, EMS, to cause excitement in the muscle tissue. This stimulus is designed to mimic the same type of signal the brain sends to the muscle when working out. There are two types of muscle fibers, slow twitch and fast twitch. Most muscle fibers contract at different frequencies. So how does muscle stimulation actually work? To be more specific, muscles are stimulated through a complex process that involves both the nervous system and biochemical reactions within the muscle fibers themselves. So let's start with the nervous system. So the nervous system signal, muscle stimulation begins in the brain, of course. When you decide to move a specific muscle, your brain sends an electrical signal down the spinal cord and through the peripheral nerves to the muscle fibers that you actually need to contract. From there, we're on to the neuromuscular junction. So the nerve signal reaches the neuromuscular junction, which is the point where the nerve meets the muscle fiber. At this junction, the nerve releases a chemical called acetylcholine into the synaptic cleft, which is a small gap between the nerve and the muscle fiber. Now we have muscle fiber excitation. So the acetylcholine binds to receptors on the muscle fiber's membrane, sarcolemma, causing a change in the membrane's permeability to ions, especially sodium ions. So this change in ion concentration generates an electrical impulse, also known as a action potential, which travels along the sarcolemma. Now we have the sarcoplasmic reticulum activation. The action potential travels along the sarcolemma deep into the muscle fiber via a network called the T-tubules. This action potential stimulates the sarcoplasmic reticulum, a specialized structure within the muscle fiber itself, to release stored calcium ions into the cytoplasm of the muscles. Now, cross-bridge formation. Those calcium ions bind to troponin, the protein in the actin filament in the muscle cell. This binding causes troponin-tropomyosin complex to change shape, exposing myosin binding sites on the actin filaments. Now for the muscle contraction itself. So myosin, a protein within the muscle fiber, forms cross bridges with the exposed binding sites on actin. ATP, which is adenosine triphosphate, provides the energy for myosin heads to pivot and pull the actin filaments toward the center of the sarcoplasm sarcomere, the basic unit of muscle contraction. This shortens the sarcomere, leading to muscle contraction. So for the opposite of muscle contraction, we have muscle relaxation. When the nerve signal ceases, acetylcholine is broken down by an enzyme called acetylcholine esterase. That's one word, a lot of letters, which stops the stimulation of the actual muscle fiber. So those calcium ions are actively pumped back into the sarcoplasmic reticulum, causing the tropomyosin complex to cover the myosin binding sites on actin. This prevents further cross-bridge formation, leading to muscle relaxation. So this process is repeated every time you move a muscle, and it happens incredibly quickly and efficiently, allowing you to perform various actions and movements. So now to combine what is EMS and how does muscle stimulation work, we're going to do how does muscle stimulation work with EMS. So basically EMS, or electrical muscle stimulation, is a technique that uses electrical impulses to stimulate muscle contractions. You kind of see it a lot in physical therapist office, athletic training, and a certain amount of rehabilitation settings. So what we're going to do is just kind of break down how they combine. So first we have the electrode placement. EMS involves the placement of electrodes on the skin over the muscles to be stimulated. So these electrodes are connected to a device that measures the electrical impulses themselves. Now the electrical impulses, when the EMS device is activated, it sends controlled electrical impulses through the electrodes and into the muscle. So these electrical impulses mimic the natural signals that come from the central nervous system that triggers muscle contraction. So the muscle fiber activation, the electrical impulses cause the muscle fibers to contract and relax in a pattern similar to voluntary muscle contraction. So this is actually involuntary. Depending on the settings of the EMS device, the muscles can experience a gentle twitch or more sustained muscle contractions. Just like with voluntary muscle contractions, the muscle fibers respond to the electrical impulses by contracting. This contraction can help improve muscle strength, endurance, and tone. Next, we have frequency and intensity. EMS devices allow control over the frequency and intensity of the actual electrical impulses. Higher frequencies tend to produce muscle twitches, while lower frequencies can result in more sustained contractions. The intensity of the impulses can be adjusted to suit the kind of individual's level or treatment goals, so it really depends. So the great thing about EMS is also the targeted stimulation. So EMS can be used to target specific muscle groups, making it useful for rehabilitation after injuries or surgeries. So by stimulating the muscles that might be challenging to activate voluntarily due to pain or immobility,